Okay, so what we're doing is the problem. This is exam 1 and the problem questions of 2023. So what the students we didn't go so well in. So here, so if we look at question 6, so 50. This is for our classes at my classes at SBC. So we got 63. So the histogram below displays the distribution of prices in dollars of cars for sales in a used car yard. The histogram has a log 10 with a base of 10 scale. We only ever have log 10, so you don't have to worry. So the important thing to remember here is that, if you see, say, this number on a log scale, what the actual number is 10 to the power of what that number is. So 10 to the power of 3. So that actually is 1,000. So if you're reading off, if you did a true scale, that would be starting at 1,000. So what you want to do is change your log 10 scales to actual numbers. So that's what you want to do when you want to answer these questions. So it said 6 of the cars in the yard have the following prices. So they've listed how many of these 6 car prices are listed in the modal category. So this could have been an issue too, that they might have not forgotten what the modal class, because we don't sort of see it often, but mode class is just the modal class, just a different thing. So what we're saying is how many of these cars listed are in that one, because it's the highest, that must be the most frequent. So really we've got it's 10 to the power of 3.5. And if you calculate that number, it's 3,162.27. And then we've got this one. So 10 to the power of 4. A quick way to remember it, it's just the 1 with 4 zeros, if you want to quickly do it. So it's any ones between 3,100 and 10,000. So if you go through, that one is above it, that one is, and this one is, and the other 2. So we've got 3 out of those are in the modal category. So I'm tipping that was just for getting log scales, because it was 50%, so not a lot, not a huge thing. All right, now the next one here was it's actually question 8. So the least squares line shows the predicted test marks for test 2 for each student on their test 1 thing. Okay, so the number of students whose actual test mark is within 2 marks of the predicted line. What they're actually saying there when they talk about that, when you talk about the difference between what you actually got, which is like the dot value, that's what you actually got, and then what the line predicts, that's what the line predicts. What that is, that's a residual. That's what actually a residual is. It's like an error, like how far off were we? And if the dot is above, we underestimated, because the line's underneath. If the dot was below, we've overestimated, so you'll get an error thing. So here they are pretty much saying like how many of these dots have a residual, like a residual value greater than, it's either greater than 2 or negative 2, yeah? Or we could say negative 2. So what we're really saying is the gap between dot and line is going to be bigger, or is bigger than, what does it say? How many are within? So are within, or is bigger than, and I'm going to say one section. And what I mean by that, this is where I think we might have got caught out, is that, see, that's a value of 2, isn't it? So if you have a look, if we go up here, so this one definitely doesn't have it's like spot on, so residual. So this, they want to know how many are within things. So if you look, can you see, if I look at this next one, I've gone more than one gap, haven't I? Yeah, so that's bigger than 2. So that one's not 1. If I look at this one here, that looks like less than 1. Do you agree? Yeah. This one definitely is. This one, no, it's gone over. That one's gone over. I'm sorry, I'm going up. Up here, no. I'm going to say this one, yes. This one, well, I'm not sure. I don't think so. I think it's bigger than 1. That one and that one. So how many have we got? 1, 2, 3, 4, 5. Oh, did I do too many? Maybe this one is too big. I think this one's too big. All right. So if you have a look, rubbing that out, we've got 1, 2, 3, 4, 5. So we've got 5. That. So this one was really the question. So you can see it was 54%. So I think that the gap of 2, you got to just make sure that you're reading the scale correctly. Now, I am actually going to go over, I do want to go over question 7 just because I'm getting a lot of questions about it, like doing this. So we'll just make sure. So with question 7, they want you need to get the equation of that line. So they're saying, what is the formula for that line, okay, which is called the least squares regression line. So what you have to do is you use 2 points the line goes through, and then you do a lin reg. So what I mean by that, you just create like a mini list in your calculator and do I just call it a lin reg, so the A plus BX on calc. Okay, so why don't I say when find 2 points, you want points that you can read off easily. So because the line's actually going through that dot, I'm going to use that one, which it says is 16 and 18. Would you agree? Yeah? And then I'll use another one that it goes through. Now, I like there, up here, because I can see that. So I'm going to use 34 and 46. So what I'm going to do is when I'm saying create a mini list, here, even if I call this T1 and T2, remember in your exam, good to try and use the codes they've got so that when you go back and check your work, it's easy to understand. And we had 34 and, what did we say, 46? And then, so what I'm saying is you pretend that's like a list. We pop it in, A plus BX. T1 was the RV, the EV, and T2 was the RV, and you click OK. So we see that it was, sorry, if you didn't see that. We see that the A value is negative 6.8 and the B value is 1.5. So it ends up being A. Now, the other things that you can do, because sometimes eliminating answers can make it easier, and you can be quicker. Now, because this is 14, that's not 0. So I know for a fact that the A value, the intercept value, would not be what it looks like there. So it is definitely not what we say 15. So I could have got rid of that straight away. The other thing to look at is, have they got the EV and the RV the correct way? If that's around the wrong way, you can get rid of that one and stuff like that. All right. Okay, so let's go to the next. Oh, sorry. Oh, no. Okay, so then let's look at question 9. Now, this was another one. So it says a least squares line can be used to model the birth rate of children per 100,000 population in a country from the average daily food. So because they're going to, really what they just said there, they are going to predict the birth rate. They said they can get the birth rate from average, or like say average food or whatever. So because they're going to predict that birth rate, you should be knowing that's the RV. Okay, when we say we're going to look at something, we're looking at the birth rate, and then this is obviously EV. Because we've got a least squares regression line, that means we must be talking about like an A plus, this must be the A plus BX, yeah? So, or the RV, and so we need to know that. So it says when the least squares regression line is fitted to the data, a selection from a selection of countries, it found that the average food intake of 8.53 got a birth rate of this, and then they said that. So what they're essentially doing there is they're giving you 2 points. So remember, if we have a point, we'd have the EV first and the RV. So here they gave me when it's 8.53, I have a 32.2, and then here if I have 14.9, I get a 9.9 birth rate. So when it says what is the slope, we know that that's the B value. So we're probably going to do exactly what we just did before. We're going to use these 2 points, and we're going to do the lin reg with the A plus BX, and we only need to get the B value. So let's pop them in. So if we went to listen spreadsheets, so they called it, I don't know, I'm just going to call it, I can't be bothered. I'm going to get food and what was it? Birth rate. So I might just call it BR. And I'm going to pop in our things. So we had 8.53 food intake gave a 32.2 birth rate, and then when we had a 14.9 food rate, we got a 9.9 birth rate. All right, so do that, and then we just go menu, start calc, A plus BX. Food was that, birth rate was what the RV, click OK. So I got a B value of negative 3.5. So I can see that B is the answer. All right, so maybe if you want just to pop it in, just so you know, 1 and 2, that's what we did. We did 8.53, 32.2, whatever, okay, 9.9. It's on the video, so then we got the B value, and we found B equals negative 3.5. All right, with this one, these ones with a lot of wording, I would advise you do these ones in your reading time, because all this one is reading and making sure, okay? So let's have a look. A year 10 study of year 10 students showed there was a negative association between the scores of topic tests and time spent on social media. So what I suggest you do with these is when they give you that information, draw up a graph and go, it said there was a negative association. So you know that means it's going down. It's a negative graph. And it said with topic test scores. So say these are the test scores, and then they went with, I don't know, the social media. So here's the social media. So, and does that sort of make sense, doesn't it? The more time you spent watching TikTok, the less time you spent studying, therefore your test scores are low. Yes? So here, this guy who spent all his time on TikTok did no studying and got a low test score. Does that make sense? Yes. So then it helps you understand a little bit. Now, they also, remember, in general exams, they're not very nasty and give information that's not needed, or, things like that. That can happen in methods, I understand that. But most of their information, you need it, okay? So they told me the coefficient of determination is 0.72. So just be careful. I always like to write straight away, so I don't get confused. That's R squared, not R. Now, because I know it's a negative, my R value will actually be a negative, won't it? And when you square it, of course, all determinations or R squared values are positive because they're negative by negative. All right. So now here when we read through it,